Good day, students. How are you? Continue our video lessons. Our topic is named the indefinite integration by parts. The indefinite integration, indefinite integration by parts. In Azeri it is hisse гейрмен интегралама. In Russian it is неопределенное интегрирование по частям. Now give the formula of the indefinite integration by parts. This formula has the following form: integral of u dv is equal to u multiplied by v minus integral of v du. Here u and v are the functions of x. Function of x. Then consider examples on the indefinite integration by parts. First example. Example 1. Find the integral. Integral natural logarithm of x dx. Or, for example, natural logarithm of, logarithm of 2x minus 1 dx. This integral isn't table integral. It is not table integral, and this integral is found by the indefinite integration by parts rule. This integral is ready to the application of this method. First, change the argument of natural logarithm. Let 2x minus 1 is t. Change. 2x minus 1 is t. Then from here x is t plus 1 in half. And then find dx. dx is equal to d of t plus 1 in half, and according to the definition of the differential, it is t plus 1 in half prime multiplied by dt, and the derivative of this expression is 1 second. 1 second dt. Apply this change. Integral of natural logarithm of t multiplied by 1 second dt. Then we can take 1 second out of the integral symbol as the constant factor. 1 second multiplied by integral natural logarithm of t dt. This integral is ready for application of the indefinite integration by parts. Let natural logarithm of t is u and t is v. Then we have 1 second multiplied by integral of u dv. Then apply this formula. We have integral of type integral u dv, and this integral is equal to u multiplied by v minus integral v du. 1 second multiply u multiplied by v minus integral v du. Then substitute substitute the corresponding expressions instead of u and v. 1 second. Multiplied by natural logarithm of t multiplied by t minus integral of t d natural logarithm of t. Here change the places of factors, cofactors. T multiplied by natural logarithm of t minus d of ln t. It is logarithmic derivative, and you know that the d ln t is t prime over t. T prime over t, and it is or du it is integral t according to the formula of differential. It is natural logarithm of t prime multiplied by dt, then equals 1 second multiplied by t multiplied by natural logarithm of t, and derivative of logarithm t is 1 over t. Integral t multiplied by 1 over t dt. Here t and 1 over t are simplified, mutually simplified, and then we have integral of dt, and integral dt is simply t. 1 second multiplied by t multiplied natural logarithm of t minus t plus c. Then we can take t out of the brackets. Then we have 1 second t multiplied by natural logarithm of t minus 1 plus c. Then substitute 2x minus 1 instead of t. 1 second multiplied by 2x minus 1 multiplied by natural logarithm of 2x minus 1, then minus 1 and plus c. It is answer of our first example. Let's consider second example. Example 2. Find the integral of x to 4 natural logarithm of x dx. Here our integral isn't ready to the direct application of the integration by parts rule, and for this introduce x to 4 into the differential sign. That is, rewrite the given integral in the following form: natural logarithm of x multiplied by x to 4 dx. Here I must give you the anti-differential table. X to 4 dx is 1/5 dx to 5. It is dx to 5. It is 1/5 d of x to 5. You can control this formula, because d of x to 5 is x to 5 prime multiplied by dx. X to 5 prime is 5 multiplied by x to 4. 5 and 1/5 are simplified, and then we will have only x to 4 dx. Rewrite natural logarithm of x multiplied by 1/5 dx to 5. Then take 1/5 out of the integral symbol, 1/5 integral natural log of x dx to 5 dx to 5. Already the last integral is ready to the integration by parts rule application of integration by parts rule. Let natural log of x is u and x to 5 is v. Rewrite 1/5 integral of u dv, and according to the indefinite integration by parts, we will have 1/5 multiplied by u multiplied by v minus integral v du equals 1/5 u multiplied by v. It is natural log of x multiplied by x to 5 minus integral x to 5 multiplied by d ln x. Change the places. 1/5 multiplied by x to 5 multiplied by natural log of x minus d ln x. It is x to 5 multiplied by ln x prime dx. Ln x prime is 1 over x. It is 1 over x and multiplied by x to 5. Then we will have it will give x to 4 equals 1/5 x to 5 multiplied by natural log of x minus integral x to 4 dx. And it is the table integral is it is equal to x to 5 over 5 1/5 multiplied by x to 5 natural log of x minus x to 5 over 5 and plus c. Then we can take x to 5 over 5 out of the brackets. Then we will have 1/5 multiplied by x to 5 over 5 multiplied by 5 natural log of x minus 1 plus c. And finally we'll have x to 5 over 25 multiplied by 5 natural log of x minus 1 plus c. It is answer of the second example. Then I'll give you the anti-differential table. Please write. Now consider the anti-differential table. The anti-differential table. The anti-differential table. First formula, 0 dx is dc. Here c is constant value. C is constant. Second, x to n dx. It is 1 over m plus 1 multiplied by d of x to m plus 1. Here n isn't equal to minus 1. and the particular cases of this formula 2a here 2a x but here the anti-differential absent. I try to enumerate these points according to the derivative table. 2b is x dx. X dx is 1 second dx squared. dx squared. Then 2c dx over x squared is equal to minus g of 1 over x. 1 over x. Then 2d dx over square root of x is equal to 2d of square root of x. Then continue. Third formula. Cosine x dx is d sine x. d sine x. Fourth formula. Sine x dx is minus g cosine x. Fifth formula, dx over cosine squared x is equal to d tangent x. Tangent x. This formula can be used in the indefinite integration by parts. Sixth formula, dx over sine squared x is equal to minus d cotangent x. Cotangent x. Seventh formula, a to x dx is equal to 1 over natural logarithm of a d of a to x. In the particular case, if a is e, here e is a constant value, approximately equals to 2.7. 7th a e to x dx is d of e to x. Rewrite these formulas. These formulas are useful for application to indefinite integration by parts. Then continue this table. Continue. Write eighth formula. Dx over x is equal to d of natural logarithm of modulus of x. Ninth formula. Dx over square root 1 of 1 minus x squared is d of arc sine x. finally write tens formula dx over 1 plus x squared is d of arctangent x. Then continue our examples. Consider the third example. Example 3. Example 3. Find the integral arcsine. Arctangent of 5x plus 2 dx. First change the argument over arctangent by new variable t. Let 5x plus 2 is t. Right change. X plus 2 is t. Then x is t minus 2 over 5. Then dx is d of t minus 2 over 5. It is according to the definition of differential, it is t minus 2 over 5 prime by dt, and derivative of this expression is 1/5 dt. Dt is equal to apply this change into the given integral arctangent t multiplied by 1/5 dt equals, we can take 1/5 out of the integral symbol. 1/5 multiplied by integral of arctangent t dt. Already this integral is related to the application of the integration by parts. Let arctangent t is u and t is v. Then rewrite the last integral for the new variables. Integral of u dv, and according to the in-depth integration by parts, integral of u dv is equal to u multiplied by v minus integral of v du. Then substitute the corresponding expressions instead of u and v. U is arctangent t, and v is simply t. Is equal to 1/5 multiplied by arctangent t multiplied by t minus t multiplied by d of arctangent t equals, then continue. They continue, change the places of these factors, equals 1/5 multiplied by t multiplied by arctangent t minus integral of t, and d of arctangent t, it is arctangent t prime multiplied by dt. And derivative of arctangent is 1 over 1 plus t squared. 1 over 1 plus t squared dt. Rewrite 1/5 multiplied by t arctangent t minus integral t dt over 1 plus t squared equals. And already you know that t dt from anti-differential table, t dt is 1 second dt squared. 1 second dt squared. 1/5 multiplied by t multiplied by arctangent t minus 1 second dt squared over 1 plus t squared. Then take 1 second out of the integral symbol, because 1 second here is constant factor, and we can also rewrite dt squared as d of t squared 1 plus t squared. d of 1 plus t squared, because the differential of sum is the sum of differentials, and differential of unit of 1 is 0, because differential of constant value is 0. Differential of constant value is derivative of constant value multiplied by dt, and derivative of constant value is 0, therefore 0. Therefore we can write d of 1 plus t squared instead of dt squared, because 1/5 multiplied by t arctangent t minus 1 second multiplied by integral of t of 1 plus t squared over 1 plus t squared equals, and it is according to the anti-differential table, it is d of natural logarithm of modulus of 1 plus t squared, modulus 1 plus t squared. 1/5 multiplied by t multiplied by arctangent t minus 1 second multiplied by natural logarithm. It is integral of d of natural logarithm of modulus 1 plus t squared. Here 1 plus t squared is positive value, therefore we can change the modulus symbols by ordinary parentheses. 1/5 multiplied by t multiplied by arctangent t minus 1 second. It is d natural logarithm of simply 1 plus t squared, and you know that the integral of differential is equal to the expression of differential. It is on the natural logarithm of 1 plus t squared, and then we must add the arbitrary constant named the integral constant, and then return to the x variable. According to the change, t is 5x plus 2. 5x plus 2. 5x plus 2. 1/5. I'm sorry. 1/5 multiplied by 5x plus 2 multiplied by arctangent of 5x plus 2 plus 2 minus 1 second multiplied by natural logarithm of 1 plus 5x plus 2 squared and plus c. It is answer of our integral. And continue. Consider the last example, fourth example, example four. Find the integral of arcsine of 3x minus 4 dx. This integral isn't table integral, and here we will apply the integration by parts rule. But first change the argument of arcsine by new variable t. Let 3x minus 4 is t equals change 3x minus 4 is t, and x equals t plus 4 over 3. Then find dx is equal to d of t plus 4 over 3. Then it is t plus 4 over 3 prime multiplied by dt. Derivative of this expression is 1/3 dt. Apply this change to the given integral. Arc sine t multiplied by 1/3 dt. Then we can take 1/3 out of the integral symbol. 1/3 multiplied by integral of arc sine t dt equals. Already our integral is ready to the integration by parts application, and let arc sine t is u and t is v. Rewrite the last integral 1/3 multiplied by integral of u dv, and according to the definition of the indefinite integration by parts, it is u multiplied by v minus integral v du. U multiplied by v minus integral v du equals then substitute the corresponding expression instead of u and v. 1/3 arc sine t multiplied by t minus integral of t multiplied by d of arc sine t equals. Change the places of these factors. 1/3 multiplied by t multiplied by arc sine t minus integral of t multiplied. The arc sine t is derivative of arc sine t multiplied by dt. Derivative of arc sine t is 1 over square root of 1 minus t squared. 1 over square root of 1 minus t squared dt equals. Rewrite 1/3 multiplied by t multiplied by arc sine t minus integral t dt over square root of 1 minus t squared. Then continue. Already you know from the anti-differential table that t dt is 1 second dt squared. 1 second dt squared. And we can rewrite equals 1/3 multiplied by t multiplied by arc sine t minus integral 1 second dt squared over square root of 1 minus t squared. Continue. Then we can transfer to the denominator and introduce negative sign into the differential symbol. Then we'll obtain 1/3 multiplied by t multiplied by arc sine t plus integral of d minus t squared over 2 square roots of 1 minus t squared. And continue. We can rewrite d of minus t squared as d of 1 minus t squared. d of 1 minus t squared. Because it is difference, and differential of difference is the differential of difference of differentials, and difference of unit differential of a constant value is 0. Therefore, it is equal to d of minus t squared. Then continue. 1/3 multiplied by t multiplied by arc sine t plus integral of d of 1 minus t squared over 2 square roots of 1 minus t squared equals it is differential according to the anti-differential table. It is integrand is equal to the differential of square root of 1 minus t squared. 1/3 multiplied by t multiplied by arc sine t plus integral of differential of square root of 1 minus t squared equals, then and you know that the integral of differential is the differential expression 1/3 multiplied by t multiplied by arc sine t plus square root of 1 minus t squared, and then we must add the arbitrary constant named the integral constant, and return to the x variable according to the change. T is 3x minus 4, and substitute 3x minus 4 instead of t. 1/3 multiplied by 3x minus 4 multiplied by arc sine of 3x minus 4 plus square root of 1 minus 3x minus 4 squared plus c. It is answer of the fourth example. Then now I'll give you your homework. homework. Find the integrals, find the integrals, find the integrals, integrals, the integrals by the integration by parts, by the integration by parts. By parts. I'll give you four integrals. First integral natural logarithems of 3x plus 2 dx. Second integral of x cubed, natural logarithm of x dx. Third example, integral of arctangent of 3x minus 1 dx. And fourth example, for example, integral of arcsine of 4x plus 5 dx. Please rewrite your homework. Our video lesson ended, and good luck, students.